Hi everyone, it's me, Mr. Lee, and today what we're going to do is we're going to do some concept builder questions. Now what I want to do is I want to do the get into the flow questions because that's what we went over. Now if you want to do the particle count, that is a-okay. It's, gives you a well-rounded idea of all the static stuff, and same with the analyze this. But let's do the get into the flow. Let's do a couple of questions. Okay. Now here it says, two lab partners are doing a static electricity investigation. They begin with a neutral aluminum pie plate. Neutral. After conducting the procedure, they observe that the pie plate has become positively charged. Which statement accurately explains how this happens? So if a object becomes positively charged, a thing to keep in mind is that only negative charges can move. So if it's left positive, that must mean that the negative charges left the object. So I'm going to choose this one. Fingers crossed. I hope I get this right. All right. I still got it. Okay, next question. Two lab partners are doing a static electricity investigation. They begin with a neutral balloon. After conducting the procedure, they observe that the balloon has become charged negatively. Which statement accurately explains how this happened? Now remember, if an object becomes negatively charged, that means negative charges were added because only negative charges can move. So I'm going to choose this one. Fingers crossed. I got it. All right, let's try this one. Two lab partners are doing a static electricity investigation. They begin with a positively charged aluminum plate. After conducting the procedure, they observe the pie plate has become electrically neutral. Which statement accurately explains how this happened? All right, so it starts off as positive. In order to become neutral, it has to gain negative charges because positive negative makes neutral. So I think it's this one. Fingers crossed. Fingers crossed. I still got it. All right, it looks like we got some good stuff here. So let's do the next one. Analyze this. I'm going to do about 2 questions of these. Oh boy, oh boy, oh boy. 2 students are experimenting with 2 objects, a neutral aluminum pie plate and a negatively charged metal sphere. They momentarily touch the metal sphere to the pie plate and pull it away. The pie plate becomes charged negatively. The metal sphere remains negatively charged, but has less excess negative charge than it previously had. Complete the analysis of this question. All right, so this is the aluminum pie plate is neutral, so these are the same. The metal sphere is negatively charged, so the E's are greater than the P's because the P's are positives and the E's are negative. They touch. And so when they touch, it says the metal sphere remains negatively charged. Okie dokie. But remember, this had a lot of negative charges, and they gave away that negative charge to the plate. And so this gained negative charge. And it says, how did the pie plate become charged? Well, because the negative charges from here jumped onto there. Let's see if I still got this. I still got it. All right, one more. 2 students are experimenting with 2 neutral objects, a foam square and a sample of animal fur. They rub the 2 together and the foam square becomes charged negatively and the fur becomes charged positively. Complete the analysis of this situation. All right, so before there are 2 neutral, okay, so neutral. After they rub the 2 objects together and the foam square becomes charged negatively, so this is negative, so it has more negative electrons, and it says this one is positive, so it has more positive. How did the foam square become charged? So this gained electrons, so that must mean that the electrons from the fur jumped onto the plate. So we can say electrons were added to it. Let's see if I still got it. I still got it. All right, so this is how you just go about it. When you're doing these, make sure you just think about it in this way. If it becomes negatively charged, that means negative charges were added to the object. If it becomes positively charged, that means positive, or excuse me, oh, almost got myself. That means the negative charge left the object. Positive charges never move. All right, so why don't you try this? There's a couple of questions that I did not do, and see how well you understand static electricity. Until next time, we'll catch you later. Bye-bye.